What's up? For vectors? Yeah. Maybe check your bag and make sure that.
I think I lost it.
Huh? All right. So we have 2 more lessons, okay, of new stuff. And then after that, finally, we're just reviewing for the AP test, which is only 3 weeks away. And then you're done with this class, okay? So here we go. Last time we learned how to find volume. You should remember that volume is the integral of whatever the area formula is across the domain. So if your cross section is a square, you use base times base. If it's a rectangle, base times height. You'll remember there was a triangle, there was an ellipse, there was a circle. Okay, so you have all these different possible shapes. Today, we're going to revolve a region around a line to create the shape, which sounds confusing, but hopefully it's not. So take a look at number 1. I want you to sketch this region. We want the square root of x, the x-axis, and the vertical line x equals 4. So let's sketch that first. So we know square root x looks like this. Okay, the x-axis is already there. And then x equals 4, we'll say is like this. Okay, first thing I want you to do is shade the region that they're talking about. It has to be enclosed by those 3 things. So I want the x-axis, the vertical line, the square root. Okay, and if I shade that in, I can see that this is the region that they're talking about. Okay. Then it says we want to find the volume of the solid generated by rotating this region around the x-axis. So I want you to imagine that the x-axis is going to be the center, and then I'm going to essentially take this piece and I'm going to spin it around like this so that it's going to create a solid. Okay, so before I try to draw it, I'm just going to show you, I found like a little applet, okay, that I think will make it make more sense. Okay, so look at this. Our equation needs to be square root x. Okay, so let's see if I can do this. Oh, that doesn't look right. Hold on. Should have already typed this in. So x to the power of 1/2. Okay. Okay. All right. You see it? Look, this is great. Okay. So here's our region. Okay, and then we're gonna shade it around the or we're gonna revolve it around the x-axis. Okay, look what happens. Very exciting. Okay, as it spins around. Ooh. You see? And then look it, I can turn it. Ooh, you like that? Very cool. Okay. So we're gonna learn how to find the volume of the solid that's created when you rotate that region around the axis, okay? So back to your little paper. So I'm gonna try to draw it, but now hopefully you know what it looks like. So you're gonna end up with, this is called a nose cone, okay? Because you don't have like a firm point at the end. And then if I were to slice into that shape, what would the cross section look like? What shape? A circle. Very good. So because this is rotating, no matter where I slice into it, okay, the cross section, meaning like the picture that you would see if you cut into it, it would be a circle. So let's put right here that because we're rotating, that automatically means the cross section is a circle. And we remember the area of a circle is pi r squared. Now, the next thing that we need to do is write the equation for the radius of that circle that we see as the cross section. So you're going to notice that, let's say I pick this circle. Okay, it really doesn't matter which one you pick. But if this is the circle that I'm looking at, my radius would extend from the center to the edge of the shape. That would be your R, or your radius. Okay, and for this radius, you'll notice that it's almost just like the base from last time. It's going to be a formula, top minus bottom. Now, for this particular radius, the top is the square root. What's the bottom? The x-axis, which would be what number? 0. So for my radius, it's going to be top minus bottom, which is going to be the square root of x minus 0. Okay, now obviously you don't have to put the 0, but just for now, just put it. Okay? And then from there, it's what we did last class. You're going to do volume equals the integral of pi r squared, where my r is going to be replaced with square root x minus 0 squared. My endpoints should be the beginning and the end of the domain. So it does tell me I have to stay in the first quadrant. So what x does my region start at? 0. And then what x does my region stop at? So then it'd be 0. Now, for a lot of these, they're going to come out complicated. This one obviously didn't. Okay, what is the square root of x if you square it? So this is really just the integral of pi x dx. What is the antiderivative of x? You're going to up the power, then divide. Okay, 1/2 x squared. So I'm going to make it pi halves x squared. And then we're going to plug in the top, plug in the bottom, and subtract. So for the top, if I plug in my 4 squared is 16. And then if I cut that in half, it would be 8 pi. So 4 squared is 16, cut it in half, makes it an 8 pi. And then if I plug in a 0, what do I get? Still 0. And then it's top minus bottom, which means that my total volume is 8 pi. Okay, for that nose cone that we saw when we kind of sketched it into the app. Okay. All right, let's do another one. Take a look at number 2. Go ahead and sketch the region for me. So our equation is our region is bounded by 2x plus 3, the x-axis, and the vertical line x equals 5. Okay, what shape is 2x plus 3 gonna be? Straight line, how am I gonna shift it? Up 3, and then if it's a 2x, I know it needs to go up. So this is a sketch, don't like count out, rise, overrun, or anything, but it'd be like that. Vertical line x equals 5, we'll say is right here. And then again, I see that I need to stay in that first quadrant, which means that when I shade, I'm not going to start shading until 0. So it'd be this right here. Okay, then it says, find the volume of the solid generated by rotating that region around the x-axis. So this is my center. And then I'm going to spin this region around the x-axis and create a solid. Okay, if you can kind of imagine, it's almost like a cone, but the top of it's chopped off. Okay. So just kind of do your best to sketch the other half of it. But then because it's rotating, automatically when you slice into it, what shape are you going to see because it's rotating? A circle. Okay, no matter where you slice into it, if you're rotating, that cross section is going to be circular. So I automatically know my area formula is going to be pi r squared. And then the only question is, what am I going to use for my radius? So in this case, you would draw it in. If this is my circle, my radius should run from the center of the circle to the edge of the circle. And then remember, just do top minus bottom because it's running this way. So my top function is what? 2x plus 3. My bottom function is, nope, it's 0. So my r is going to be 2x plus 3 minus 0. Because the top edge of your radius is on the line, the bottom edge is on the x-axis. I don't be good about it. Or I have an app. All right, then from there, we're going to turn it into volume by doing an integral. So it'd be volume equals the integral of pi r squared. And then where my r is, I'm going to plug in that top minus bottom through my region. So it's 2x plus 3. Technically, there's a minus 0. We're not going to put that. And then what will the edges of my integral be from where to where? 0 to 5. Now, for this integral, you would have to do u substitution. Here's why. It's not just x squared. It's 2x plus 3 squared. So let's think through u sub. I think we're only doing this last one by hand. What would you choose as your u? Okay, so my u is going to be 2x plus 3. What does that make my du dx? Just a 2. Which means that my dx will go up, my 2 will go down. So a du over 2 is going to replace my dx. So let's rewrite our integral. It's going to be pi times u squared. And then my dx is now a what? Du over 2. So rather than me putting the over 2 here, I'm just going to put it here with the pi. Just because it's the same in both spots. So if you want to think about it as a half at the back or a half in the front, it's the same thing. Okay, from here, we're ready to take our antiderivative. What happens when I do the antiderivative on u squared? It'll go up to a u 3, u cubed. Put it in brackets now because we're taking the antiderivative. And then after I get the u cubed, I have to divide by 3, but I already have a 2 here. So the 2 and the 3 will multiply together and make what denominator? A 6. So you should have a pi over 6 u cubed. Remember, no need for a plus c because we have endpoints. Can I plug in my 0 and my 5? Not if I want to leave this a U, right? If I want to leave this a U, I have to take those endpoints, plug them into my U, and change them to whatever the outcome is. So let's say I'm doing a 5 first. What's 2 times 5? Plus 3. We're plugging in a 13 on top. And then on bottom, we're plugging in a 0. 2 times 0 is 0, plus 3 is 3. And then remember, you would plug both of those in and then subtract. So final answer here would be pi 6, 13 cubed minus 3. Now, notice that technically, they both have a pi 6. So if you just kind of GCF it to the front, that's what I would do. Or you could give them each their own pi 6 to go with them. Okay. All right. Last one we're going to do from the front is going to be number 4. We're going to skip 3. Okay. So number 4, you're going to need an equation for this one. So go ahead and graph square root 9 minus x squared and y equals -1. Okay, go ahead and sketch those two into your y equals. Okay. Okay, now when you hit y equals, if you have an R here, that means you're in polar. So just reset your calculator and it'll go away. So second plus 712 to reset. Okay. And then we're going to graph these two. We're skipping number 3. We're just going to number 4. Anybody need help resetting? Second plus 712. Okay, then once you have it graphed, just sketch it on your picture and then shade where it's talking about. They don't touch. Okay, so I have a little kind of half moon on top. And then we have a -1 on bottom. Okay. Now, notice that your graphs don't touch, but that's okay because it tells you where to shade. Where am I going to shade between? -2 and 2. So I might need those intersections if it didn't give me what to shade for. Okay, but I know that this side is going to be -2. And then I'm going to stop shading at +2. Okay, so remember, this is the x-axis. And this is y equals -1. Okay. So let's read it. It says, I want this one to be the top, bounded above. And I want the y equals -1 to be the boundary on the bottom or below. Okay, so we have that. Then it says, find the volume of the solid generated by rotating that region around y equals -1. So now the center of your rotation is going to be here. Okay, and then I don't think I've called it this yet, but that's called the AOR, or the axis of rotation. Okay, and so a lot of times they will just pick the x-axis because it's easy, but if they pick another line, it's okay. That's going to be your center. So now think about if I take this region and I spin it around that pink line, can you kind of visualize it be almost like a bead shape, but it wouldn't have a hole in it? Okay, so it'd be kind of like this. Okay, it doesn't have to look perfect. Okay, but it'd be kind of like that. And no matter where you cut into it, because it's a rotating solid, what is your center cross section going to be? What shape? A circle. Okay. So I'm going to put here area equals pi r squared. And then I just need to know, what am I gonna use for my R? Well, remember, the R has to start at the axis of rotation and then extend to the outside of the circle. And then remember, I'm doing top minus bottom. So what's the top? Square root 9 minus x squared. And then what's the bottom? -1. So your R in this case is going to be 9 minus x squared minus -1. Remember, it's always top minus bottom. Okay, but when we're saying top minus bottom, we're talking about the top of the shaded region minus the axis of rotation that you're revolving it around. Okay. All right, from there, let's put it into our integral. So it's going to be volume equals pi r squared, where my r is going to be 9 minus x squared plus 1. Okay, notice a plus for this minus. Okay, then what are our endpoints? -2 to 2. Okay, so let's put it in the calculator. Okay, to get the answer, because this one would take forever to do by hand. All right, so first thing I want you to do is get into your normal home screen. You're going to hit Math 9, -2 to 2. Okay, you're going to type the pi first, and then you need to open your own parentheses. So it's going to be parentheses. I'm going to use my y1 plus 1, and then squared. Okay, you cannot use the parentheses they've given you because the pi is not part of the square. So you have to open your own parentheses here. Okay, and then just push out. Just give you the answer. Okay, so 178.273 is correct. Questions on that? Good? Okay. All right, so turn the page. So the entire next page was copied by mistake because I'm a D2D. So you can skip this whole page and go to the next one. Okay, it's right here. Okay, we're not doing any of this today. All right, so we're gonna start right here. Okay, and I'm gonna kind of use the space from number 8 to put what was supposed to be there. What you just learned is called disk method. Okay, and the reason that it's called disk method is because whatever your region is, so let's say we're shading from here to here. Okay, the line that you're rotating it around is also a side for that shape. Okay, so what that means is that when I rotate this yellow region, I'm rotating it around a pink line that's already fully adjacent to that shape. So what happens is when you're rotating it around, I wish I'd picked an easier shape though. Okay, you end up with what shape for the cross section? It's always a perfect circle. Okay, so I'm gonna put here, because you're rotating around an AOR that is adjacent to the region, your cross section is always a circle or a disc. So your volume is going to be pi r squared and then integrate it. Okay, just like we just did. That it'll be pi r squared because it's always a circle if you're rotating around an adjacent line. So let's fill in the blanks. It says in all the examples we just did, region R was adjacent to the axis of rotation. That's basically what you just wrote. So it's called disk method. Because the figure is a circle. Okay. So now what we're going to consider is, what if this pink line that you're rotating around, what if it's a little bit off from where the region is? Okay, what would the cross section look like then? Okay, huh? Yes, wow, good. Oh. So draw me the same kind of picture. Shade the same kind of region. But this time, instead of rotating around the x-axis, I want you to pick a different flat line that's not already right up next to the yellow. So this is going to be my AOR. And remember, AOR is basically what I'm rotating around. Okay, so remember the applet, that this is going to spin around that line. What shape is it going to make? Is it going to still be a perfect circle when you cut into it? What's going to happen here in the middle? You're going to have like a weird hole or a gap through the middle of it. Okay, so what's going to happen is your center, go ahead and try to draw this for me, but it's okay that it's probably not going to look very good. Okay, you're going to end up with a hollow core in the middle. And then you're going to end up with a solid that's going to have that hole through the middle of it. Okay. So if you kind of like turn your head, it's like almost like it's like a volcano, that you're going to have this whole shape, but then that whole center of it is like cut out. Okay. So once again, the difference here is that rather than your cross sections being a perfect circle, they're a washer. Okay, washer refers, like, you know how you like drill into it and it's like the little metal circle. Okay, so I prefer to call this the donut method, okay, because everybody knows what a donut looks like. Okay, but that would be this shape where it's like a circle with the core missing. Okay, so this is washer method. Okay, now think with me. If I want the shape of this donut, what am I going to do with the areas for the circles? Subtract them. Specifically, I'm going to do big circle minus little circle, and that'll tell me how much area is actually in the donut. So write down your volume is going to equal pi big R squared minus pi little r squared, where this is going to be the big circle and this is going to be the little circle. So if you have a gap between your region and what you're rotating around, you're going to have two radius measurements, one for the big circle and then another one for the little circle. Okay. Now, when you're typing this into the calculator, you should just pull this pi out. So I'm going to rewrite this here, okay, where the pi is on the outside, and then you're just going to do big R squared minus little r squared. Okay, this will be a lot easier for you to type in if you just put the pi in the front. That way it's distributed to both of them and you don't have to put it twice. All right, then let's draw in your two R's. Capital R needs to start at the axis of rotation. and it needs to go to the farther away function. Okay, so capital R needs to be the longer radius. And it's going to start from the axis of rotation to the farther away function. Little r is going to still start in the middle, but it's going to go to the closer function, or the shorter radius. And then remember, it's still big circle minus little circle. So big pi r squared minus little pi r squared. Okay. All right, so let's do an example. Go to the next one. We have y equals x squared plus 1. Okay, so x squared plus 1 is going to be a quadratic starting at 1. We're going to make it go up like that. And then y equals 1 is going to be a flat line like that. So this is x squared plus 1. This is 1. Where are we going to shade between what interval? From 0 to 2. So let's say 0 is here, and then we'll shade till 2. But remember, my goal is I want to stay between those two functions. Okay, then it says, find the volume of the solid formed by revolving around the x-axis. So the x-axis is right here. Okay, the pink line is the x-axis. That's my center of rotation. So here's the question you have to ask yourself. If this is the axis of rotation, do I have a gap or no gap? I have a gap, then I have 2 r's. Draw big R for me. It should start at the axis of rotation and reach to the farther away function. So big R is going to be from here to here. And little r is going to be from here to here. So big R should reach to the farther away function. Little r should go to the closer one. Okay, but they're both top minus bottom. So for big R, what's the top of the radius touching? What function? X squared plus 1. And what's the bottom of that one touching? The x-axis, which means that it would be x squared plus 1 minus 0. Okay, for little r, what's the top of it touching? 1, and what's the bottom of it touching? So it'd be 1 minus 0. And then from there, you're ready to do your formula. So it'll be volume equals pi integral. Remember, we're intentionally putting the pi on the outside so that we don't have to put it twice. It's going to be the big R first, which is x squared plus 1, minus the little r second, which 1 minus 0 is really just. And then what are the endpoints of my region? 0 to 2. Okay. And then don't do weird stuff. Don't just like cross the ones out. That's not a thing. Okay, just put it in the calculator the way that it is. But don't actually do it, but just like you would do, you know? Okay, we're going to do one more. And then we're done with notes. We'll do a question off your homework together, and then y'all have the rest of the time for it. Okay, skip to number 11, please. Okay, last one we're doing off your notes. Sketch the graph. It needs to be bounded by 4 minus x, the x-axis, and the y-axis. So we'll say 4 minus x. What shape is that? The line. Where is it going to start on the y-axis? 4. And then if it's a negative x, it needs to cut down. So we'll say 4 is here. Okay, there's my line. Y equals 4 minus X. Okay, then I see that I have the X-axis, the Y-axis, and that line means this region is right here. Okay, I know where the region starts because the Y-axis is a boundary. What X is the Y-axis going to be? 0, but I need to know this end. So remember, if you need to find an X-intercept, you just take the equation and set it equal to 0. So I would take my 4 minus X and let it equal 0. And that would be really easy to solve. Just add your X across, what does it equal? So plus X means X equals. Okay, then it says, find the volume of the solid. We have our region that's going to revolve about the X-axis. So where the X-axis is, will there be a gap or no gap? No gap. Then is this disc or washer? Disc. Very good. So put here, there is no gap. That means that this is washer. Okay, and the good news about washer method is you just have one, oh wait, dang it. And the good news about disc method is that you only have one R because you don't have the gap. So my R is going to be here to here. And then remember, it's top minus bottom. So what would the top be? 4 minus X minus 0. Okay, because the bottom or my axis of rotation is the X-axis. Okay, then let's write our volume. It's going to be pi R squared, where my R is going to be the 4 minus X minus 0. What are the end points of my region for me to integrate between? 0 to 4. Okay, and then you would just, for the homework, put it in the calculator, round the answer to the nearest cells. Now, let's say same region, but we're going to switch what we're rotating it around. So I'm going to do a quick sketch of the same region, but now we're going to rotate around Y equals 4. So we already know this is 0. We already know this is 4. Okay, but if I'm rotating around Y equals 4, that means my axis of rotation is up here. Remember, that's called the AOR. Okay, so question, do I have a gap or no gap? Yeah, and if there's a gap, that means that this is washer method. Okay, and if it's washer, you're going to have 2 R's, but they both start at the axis of rotation. Capital R goes farther than little r. So capital R is going to go from here to where? All the way to the X-axis. That's big R. And then little r is going to go from here to here. Okay, because remember, little r has to be shorter. It has to go to the closer boundary. But then remember, they're both top minus bottom. So for big R, what's the top of it touching? What function? 4. And what's the bottom of it touching? 0. So it'd be 4 minus 0. And then for little r, what's the top of it touching? 4. And what's the bottom of it touching? 4 minus X. So it'd be 4 minus 4 minus X. And then what would happen with the 4 minus 4 part? Cross it out. What kind of X would be left? Minus and negative would be a positive. Okay, then set up your volume down here. Pi on the outside. We're still going 0 to 4. And then I want big R squared minus little r squared. My big R was just a 4. My little r was just an x. And then for this one, if you had to do it by hand, since it's pretty simple, okay, it'd be 16 minus x squared. Would you need u sub on it or no? No, this is regular. What's the antiderivative of 16 minus x squared? 16 would go to 16x. And then x squared would go to a third x cubed. Okay, then you would plug in the 4, plug in the 0, and subtract. 4 times 16 is 64. And then 4 cubed is 64 again, so it'd be a third of 64. What happens when I plug in 0? It'd be 16 times 0, and then minus 0 cubed is still 0. So then remember, it's this minus 0, which means that your final answer would be 64 minus 64 thirds. Okay, almost. Why would this be wrong? Don't forget the pi, just put it back in your final answer. Okay? So if you have to do the integral by hand, okay, just ignore the pi, leave it in the front, and then when you're done, just put it back to church. Okay? All right, we're gonna do one disc off the homework together. So if you want some scratch paper, I'll bring it around. Go ahead and log in, please. Didn't know you want that? No. Little paper, please. Okay. Start. Nothing on paper? Paper over here? Okay, and then we're gonna do the first of the washers. I feel like this is separate. Yes, you want paper? Yeah. You want paper? Are all your friends at 8? 9. Aww. Parents at 8. Yeah. No. 5 of them. I don't even think I've given you 14. No, you're on homework 9. No, wait, do you need for the full year? So sure.
8.
Wow. Okay, once you're logged in, go ahead and put both of the equations into your calculator and find those two intersections. No, it's the first of the washers. Yeah, you have a calc for half of it. But for the half that you do have a calculator, it'll be like stuff you put it by hand if it's meant. Like you wouldn't like be doing the integrals by hand. You'd be just typing it in. Okay, so first thing you should be finding is these two intersections right here. All right, let's type them in. What? Didn't you just use Google? So ln 2x. And then 1/2 x. It's down kind of by the on in the floor. It's the first of the washers. So first thing you need are those intersections. Remember, you have to go to 3 decimals or it'll kind of wrong. And remember, it's second trace 5 for the intersections. Sure.
Thanks. Second
trace 5, and then make sure you're closer to the one you want. So I already found the second one if y'all want to find the first one. 7.385. What is it? 2037. So then we round it to 204. Let me see. Oh, you forgot it's 1/2 x minus 1. Oh. Okay, so you should have found those intersections. If you didn't, they're on the board. Okay, 0.204 is the first one. 7.385 is the second one. What does it say I'm rotating around? Okay, and y equals -3 is down here. So is there a gap or no gap? There's a gap, then that means you have 2 r's. So capital R should go from here to here. And then little r should go from here to here. Okay, but notice that they both start at the axis of rotation, but big R goes to the farther away function, little r goes to the closer function. But remember, they're both top minus bottom. So for big R, what's the top of it touching? ln 2x. And then what's the bottom of it touching? -3, right? Because I'm stretching from here all the way to the axis of rotation. Okay, then for my little r, what's the top of it touching? 1/2 x minus 1. And then what's the bottom of it touching? -3. So it's a 1/2 x minus 1 minus -3. And then if these are both minus negatives, we can just switch them to plus. Okay. I'm going to make it plus and plus. Now for this one, if it's a -1 and a +3, what is that the same as? So my r is really going to be 1/2 x plus 2. And then big R is fine with it is. Okay, so write your volume. It's going to be V equals pi in the front. Remember the endpoints of my integral should be those intersections that we found. So 0.204 on bottom, 7.385 on top. Big R is ln 2x plus 3 squared minus little r is a 1/2 x plus 2 squared dx. Okay, there are a billion ways you can type this in wrong. So make sure you have to open this parentheses to square it and this parentheses to square it. The calculator is going to open a parentheses for you at the beginning. Okay, but those red ones you can't use. You have to put your own to square this minus your own to square this. So go ahead and type it in. Make sure your pi goes at the front. Yes, Rebecca? What did you say? Oh. Okay. So we're putting the pi first. Okay, so you can look at mine, 165 is the correct answer. Okay, notice for my ln of 2x, I subbed in the y1. But for my 1/2 x, I simplified it, so I did not use y2. I used 0.5x and then plus 2, or 1/2 x plus 2. Okay. If you forgot the pi, just take your answer, multiply it by pi second. And then when you type it in, you're rounding to the third decimal. Third decimal. Okay. And the correct answer should be 165.78. You square big R on its own, minus, and then you square little r on it. Ooh, and then y'all look. After you get it right, it'll let you like, look at, see the shape? Look at it. Wow, very cool donut, huh? Look at that. Okay. All right, you have like 40 minutes.